Welcome to the Math Record. For the first week of May for our whatever class, we're going to be deriving circular formulas from polygons and limits. So imagine we have like a regular circle, like this. So how will we derive the area of this circle and how will we derive the circumference, like a general formula? So imagine instead of using a circle, right, just by itself, let's imagine we have like a polygon with n amount of sides. So this one has 3 sides, this one has 4, this one has 5, and this one has 6, right? So it's a triangle, a square, pentagon, then a hexagon. So as we increase the amount of sides, you can see that the area outside the shape is getting smaller every single time. So if we increase the size to infinite amount of times, we should be able to get into a circle. So what we have to do is basically, if we keep, since the radius of a circle is constant, right, then everything from the center to each of the vertices has to be constant. So we could just label those R, right? Like this one would be called R, this one would be called R, and this one would be called R. Okay, now let's first derive the area, the formula for our area of a circle. So how do we get the area of a shape? Well, let's just talk about this more in general. Since we're gonna be working with angles, let's just kind of think about the angle that's around here, like a little mini circle. So if we had to split this up, like a triangle, we have 3. Okay, that's interesting. Now with the square, if we had to split it up, we have 4. Okay. Now with the pentagon, we split it up, we have 5. And with the hexagon, if we split it up, we have 6. So why is that? So the reason it's really important to know that is because if we have 3 angles, we also have 3 sides. We have 4 angles, we have 4 sides. We have 5 angles, we have 5 sides, right? So what we could do is that if we want to find the area of this, we could use a formula which is of a triangle. If this is let's say this is x and this is y, and this one's theta, then the area of this triangle is going to be x times y times sine of theta divided by 2. That's just a trig formula that works. So basically, what we have is we have 3 triangles that are the same, and then in the square we have 4 triangles that are the same, in the pentagon that's 5, and this one's 6. So if we had to make a general formula, then basically we just had to have one of the triangles multiplied by how many of those triangles are there. So we have a length r and a length r, so that's r, right? Because it was like x times y times sine of theta divided by 2. So your x here is r, your y here is r, your sine of theta, so we need to find your theta. So we have r times sine of theta. So our theta is going to be this angle, right? So what is this angle? Well, an entire circle, right? That's 360 degrees, but in calculus, which we're going to be using, we actually use radians, which is 2 pi. Okay, so we have 2 pi radians, and we have to divide that by 3, right? But that's the amount of sides. So instead of saying 3, let's say in general, we have n amount of sides, right? Because if we have 3, then we have 2 pi divided by 3. If we have 4, we have 2 pi divided by 4. If we have 5, we have 2 pi divided by 5, right, etc. So this would, and then divide by 2 would get us the area of our triangle. So if you want the entire area of the shape, we just multiply by n, because there's n amount of sides, so there are n amount of triangles. Okay, so now we can find the area of this. So r and 2 is constant, so we could just put r squared over 2 times sine of 2 pi over n times n. And then n has to go from go to a really, really big number. So what we could do now is that we could use a limit. So as n approaches infinity, we have r squared over 2 times sine of 2 pi over n times n. Okay, so r squared over 2 is a constant, so we could just write that outside. So r squared over 2 times limit of n approaches infinity, and we have sine of 2 pi over n times n. So what do we do now? If we plug in like infinity, like a really big number here, sine of 2 pi divided by infinity, 2 pi divided by infinity is going to approach 0. So sine of 0 is 0. Okay, so as And then for this n over here, it's going to be infinity. So it's going to be a 0 from here times an infinity. So the reason we did this is that there is a thing called indeterminates. Determinates, right? When we have indeterminates like these, we basically could just get it into a form that is either 0 divided by 0 or infinity divided by infinity. And then we could use something called L'Hopital's rule to simplify to find what this come out to later on. So using this, we could say the limit n approaches infinity. So since this is 0 times infinity, to make it 0 over 0 or infinity times 0, and I mean infinity divided by infinity, all we have to do is just divide by the other one, or divide by the reciprocal of the other one. So making it easier, we just put the sign on the top, and then on the bottom, we just have divided by 1 over n, right? Because dividing by something that's already dividing, that's just the same thing as this. So these are both exactly the same thing. And now using L'Hopital's rule, we just do the derivative of the numerator and derivative of the denominator. So that will give us sine. The derivative of sine is cosine, 2 pi over n. So we have to chain inside. It looks kind of bad. Okay. And then the derivative of inside of 2 pi over n, that is just negative 2 pi over n squared. Okay. Now derivative at the bottom, that's just negative 1 over n squared. And now what we could do is we could cancel out the negative, and then we could cancel out the 1 over n squared from these two. So all we are left with is the limit as n approaches infinity of this, which is cosine of 2 pi over n times 2 pi. Okay, so as n approaches infinity, right here, 2 pi divided by n, that's going to become 0. So cosine of 0 is 1. Okay, and then 2 pi is a constant, so it's just multiplied by 2 pi. So as limit as n approaches infinity, cosine of 2 pi over n times 2 pi is going to approach 2 pi. Okay, so we know that's true. So all of this substitutes for this. So now we have the r squared over 2 times your 2 pi. So then the 2 cancel each other out, so you have pi radius squared. And that is your formula for your area, which is true. Okay, so we got this formula. Now we could do the same thing with circumference. So we just need to get one of these lengths. So imagine we had this length, this length, and this length, right? And now we have these 4 lengths. If we add all these lengths up together, sooner or later it's going to reach the entire circle. So what we have is that we could use another limit. But first we need to get one of these side lengths and then multiply it by the number of sides. So what we do is that we can split it like this. So we get half that angle. So instead of 2 pi over n now as the angle for theta, we have 2 pi over n divided by 2. So that's just going to be pi over n. So we have sine of pi over n, right? So we have r times sine of pi over n. That gives us this length. So we want both lengths, so we need to multiply by 2. Okay, so we got that. So now we just need to multiply by n, because that gives us our entire side lengths, the sum of our side lengths. So basically, now we do the same thing with another limit. So limit as n approaches infinity of 2r times sine of pi over n times n. So 2r is a constant, so we could rewrite it as 2r times limit as n approaches infinity, and we have 2r times sine, infinity of sine of pi over n times n. Okay, so we could do the same thing. If n approaches infinity here, that means pi divided by infinity is 0. So sine of 0 is 0. And n approaches infinity, that's infinity. So this got to be a 0 times infinity indeterminate. So we could just rewrite that and say it's a limit as n approaches infinity of sine of pi over n divided by 1 divided by n. So we could use L'Hopital's rules again, do the derivative of the top and the bottom. So that's cosine of pi over n times chain inside, which is pi derivative of pi over n is negative pi over n squared divided by, now derivative of the bottom, that's negative 1 over n squared. So cancel out the negatives, cancel out the 1 over n squared. So now we're left with the limit of n approaches infinity of cosine of pi over n times our pi. And as n approaches infinity, this pi over infinity is 0, so cosine is 0 is 1 times your pi. And that just simplifies the pi. So this entire thing simplifies to pi, which you could substitute right here. So we have 2 times radius times pi, which you could just rewrite as 2 pi radius, which is your circumference of your circle. So that is a way to derive the formulas for the circles for area of circumference using polygons and limits. Thanks for watching.